Hey, listen, you guys. If you're working, work. Keep it down. I'm going to go over the problems. If you need it, if not, okay, just keep working. But I will go over this. So everyone, and it is going to be kind of an abbreviated lesson because I just set down my marker. There it is. Vectors, dot product. Okay. All right, so scalar is a magnitude of a quantity and can be represented by a real number. Vector in a plane is a directed line segment. Okay, so this is starting at O, going to P. Okay, O is the initial point, P is the terminal point. Magnitude is the length of a vector expressed as, it has the bars. So OP. So two vectors are equal if and only if they have the same magnitude and same direction. This one, they would have the same magnitude. Say yes.
No. Yes.
Same magnitude, they're the same length. But are they the same direction? Say no.
No.
No. This one's pointing up, this one's pointing down. Okay? So, it has to be both. Okay? Vectors OP have the same magnitude but opposite directions. So, it's not going to work. Okay, so right here I have A and B are the same, C and D are the same. A is not the same as E. Wherever, there's. So A is not the same as E. They're going different directions. Okay, and A is not equal to F. So if you notice they're going in the same direction, but are they the same length? No, they're not. Okay. Sum of two vectors also a vector. Vector sum A plus B is called the resultant. Okay, so it's tip to tail. You'll see it here in a second. All right. Opposite vector is negative. Magnitude is 0. 0 vector. Okay, so you know what? Here's a whole bunch of blah 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 blah. Okay, scalar is multiplying the vector by some number. Scalar multiplies the vector by a number where the magnitude, okay, whatever the size is. Okay, vector with the initial point at the origin is called a positive vector. A position vector u with its endpoint at the point AB is written as vector AB. So vector AB starting at the initial point. Okay, the numbers A and B are horizontal component and vertical component respectively of u. So it's basically the x direction and the y direction. Bam. Magnitude is the length. We just used Pythagorean theorem to find it. Because I have an x direction and I have a y direction, right? So Pythagorean theorem all the way. That's what you get. Okay. And direction angle theta satisfies here. But if I want the angle, you have to do the inverse. Thank you. So I'm going to say theta equals inverse tan of I did not do that, girly. That was a very manly. B over A. It's not like I'm recorded or anything for prosperity. All right. So this is a formula, and I'm pretty sure I had it in my notes last year. You guys need to have this also. So if you guys watched the video, it was on there too, right? Yeah. Yeah. Okay, good. So necessary. Let's keep going. All right. Find the magnitude and direction for this right here. Magnitude. What does I say magnitude is?
Same length.
Magnitude.
Same direction.
Try again. Magnitude.
Same force. Same length going different.
Say length. What is the magnitude?
Same length.
Magnitude is the... No, I don't want same length. Just say magnitude is the length. Length of a vector. Magnitude is the length of a vector. Magnitude is what? Very good. The length of a vector. And how do we find that? Say Pythagorean theorem.
Pythagorean theorem.
All right, Pythagorean theorem. So if I'm going to do Pythagorean theorem off of it, it's going down 2 and right 3. Okay, so my distance, u, or another way of writing it would be saying, okay, it's going to be magnitude, so it's my magnitude bar, looks like absolute value, is equal to, okay, so it's the square root of 3 squared plus negative 2 squared. When I square that negative, it's going to clear it up anyway, right? It's going to make it a positive. So 3 squared is 9, and 4 give me 13. So I'm going to have square root of 13 is my magnitude of u. Say yes.
Yes.
Okay, good. The next thing is direction angle, right? Direction angle. So I'm going to go back to this one right here. Direction angle is B over A, right?
Yeah.
B over A. So let's take a look. In this case right here, it's going to be B, which would be opposite over here, right?
Mm-hmm.
Over adjacent over here, right? That's tangent anyway, isn't it?
Yeah.
B over A. So, all right, so let's go ahead. So what I am trying to do, so this is what's going to happen here. So for this, I want you to look closely. So I'm going to find this angle first. I'm going to find this angle because it always works according to where my x-axis is. It's always going to work like that, according to wherever my x-axis is. Make sense? Okay, good. So let's do my theta. So theta equals inverse tan of, okay, this is going to be negative 2, right?
Yeah.
Over
3.
So I can't remember if this one actually gave the issue or the other one gives the issue. But I'll find out here in a second.
What's the issue? Oh, he said something about issue.
All right, so this angle's what? Negative 33.7 degrees, right?
Yeah.
Okay. So is this the angle I'm looking for? Look at the graph.
No.
It's not.
It's in the negative swings. Yeah.
Okay. So it's down here, right? It's this way. I don't want that.
I want the other way.
I want it going clockwise. I want it going clockwise from here, going that way.
At 360.
Very good. I want coterminal, don't I? So if I start off with a negative, I need to add 360 because I want coterminal. I want it all the way this way instead. So all the way around, so that's plus 360. We get what? Theta?
336.
Very good. It's not too bad, right? Now, you're always going to find the angle from, this is going to be 0 right here. 0. It's kind of like the unit circle. I'm starting here, and I go this way around. So wherever my direction goes, I need to start here and go around. Yes?
You're 10 off. It's supposed to be 326.
326?
Yeah, 36.
He said 336.
I literally need to find it as that.
All right, fight. Who's going to win? Someone show their math.
Oh, I got it right for you.
In your old video, it said 336.
Okay, my bad. 336?
Yeah, in your
326.
Yeah, in your old video, it said 336.
Yeah, 326. It is 326. I might have had a typo on it. Sorry. Okay, it might have been a typo, like when they were telling me what the answers were. So, all right. You guys ready?
No.
All right. Are we okay over there?
Bottle.
If I
Oh.
put candy, I am.
Okay. No, not yet.
It's just something.
All right. Blah, blah, blah. There's a way of actually doing it in the calculator. So, TI Inspire. For the vector, type unit V. Your calculator will do this for you.
Isn't the other way easier?
This way is actually pretty darn easy. So crap. Let me see. It says unit V, 3, -2. So, U, N, I, T, V. I think brackets are right there. Okay, and it is, let me see my notes. 3, -2. Comma, another comma, -2. There we go. So, this part right here is going to be important for later. Wrong one. There we go. All right. So, I got this one right here for the angle. Now change this to polar. Change this to polar. So, go up. So I'm going up, taking that answer. I'm going to triangle. P O L A R. There we go. Enter. Now, what's the issue I have? What's the issue here? Yep, I need to have degrees. So I even said that even in the notes it actually says that it has to be in degrees. There you go. Go up again. Do the same thing. Hit it. So there it is. That's my angle, my -33.6, right? Say yes.
Yes.
Very good. So the calculator just did all that for me, right? So my calculator, all that work I just did, it could do, right? Okay. So that's only if we pay attention.
What?
Exactly. All right. The horizontal and vertical components. Respectively, of a vector u having magnitude u and a direction angle theta, it's u, so it's a magnitude of u times the cosine, magnitude of u times the sine. So it comes out to be u cosine, comma, u sine. All right, it has a magnitude and direction. Okay, here. Find the horizontal and vertical components. Okay, horizontal vertical components. Okay, horizontal and vertical components. Wrong way. So u, in this case, would be what? My magnitude is 25 times cosine of my angle, which is 41.7, comma, my other one is going to be 25 sine of 41.7.
Does that give you the answer? You gotta put in some other things.
And it's going to tell me where it ends up at. Now, what's 25 cosine 41.7? Cosine
18.7 and
18.7.
yeah, 16.6.
So, what is my vector here? I did my horizontal component here and my vertical component here. So, my A is 18.7 and my B is 16.6. Okay. Easy? Okay. Write each one in vector. AB. All right, let's start with U. U.
That's funny, you said the same thing in your old video.
I know. I recycle my jokes too. All right, so it's going to be, the magnitude of U is 5. 5 cosine of 60, comma, and then it is 5 sine 60, right? So cosine of 60 is 1/2, so this is 5 or 2.5, right? Comma. Sine of 60 is rad 3 over 2, so 5 times rad 3 over 2 is, what is it? 4 point. And this one is my U. All right, let's do another one. Let's do V.
Wait.
2 cosine
V. Let's see, it's going to be 2 cosine 180, comma, 2 sine 180. So cosine at 180 is -1, right? Or negative, yeah, cosine is -1 times 2 is -2, and sine at 180 is 0. So my direction is, from my point of origin, is 2 to the left and none up, right? Okay.
Got it?
We also have W. So W is 6 cosine of 280, comma, 6 sine of 280. All right, what did we get? 6 cosine 180 or 280?
1 and negative 5.
1 and -5?
-6.
Nope.
You're saying 1?
It's 5.90.
1.
Yeah,
No,
that's
for the other one.
Okay, 5.90. So it is -5.90.
So wouldn't that still be 5?
Let's go -6. Okay, or -5.9. Either way, still fine. 1 decimal is good. Okay. Is that super easy now?
Yes.
Yes, I just did an entire semester's worth of physics in about 15 minutes.
I need saying you calling the physics teachers dumb now?
No, I just summarized it into.
What?
You're saying you're better than them?
I said I summarized it.
When you ready for that test?
over here, please. All right, so for this right here, we have force. So we're going in two directions here, right? Okay, so where was I thinking? Properties, parallelograms. Okay. Okay, so parallelogram is quadrilateral whose opposite sides are parallel. Okay, they're going to be parallel. And opposite angles of parallelogram are equal. Adjacent angles of parallelogram are supplementary. The diagonals of parallelogram bisect each other, but do not necessarily bisect the angles of the parallelogram. So, if that is 100, that is 100. If that is 80, that is 80. Yes? What?
Does it have to be the same, right?
Okay, so they're parallel. So it is going to go in two different directions here. So parallel, so now I know a couple things. So with this, I actually have two different forces. So think of it like this as you're walking two dogs. You're walking two dogs. Have you ever walked two dogs? Okay, they don't like peeing on the same thing, right? They want to go in different directions. So we have, let's say for instance, I have some person walking their dog. They have their cockapoo, which is 15 pounds, and it's going to the left.
And then my fat chiweenie that's like 45 pounds.
Yeah, that chiweenie, 45 pounds, or 22 in this case. Okay, so this one is actually pulling that far. Okay, pulling in that direction. Okay, so together, I'm actually going to get a vector in between there, right?
Yes.
Okay, so from this one right here, let's see. So we have, starting from here, going this way, right? Yes?
Yes.
So the angle between, I think I'm missing a slide. I had a formula here. I thought I had a formula for this.
There's a formula next slide.
Pythagorean theorem, right?
No, it's I have a formula here where for the newtons and stuff like that.
Yeah, I don't see it much of it. Can you memorize it?
No, I can't remember right now, so that's why I'm like, snap, I forgot it.
You gotta remember like last time?
Did I forget the video too? Oh no, yes? Like last time, I'm like, crap, forgot. Okay, so we gotta get a vector off of this. Okay, so that means that if it's there, I am
Pause the video.
There's an
I know, I should pause the video.
There's an equation right here.
You have it? Okay, so I totally forgot what I was doing, and so now I'm back. Back again. Shady's back. Alright. Alright, so now for this one right here. So, okay, watch this. So 22's here, and I'm going to call this one A, this one B, and this one C. Alright, so I need to try and find this length right here. So, for this one right here, I know this one right here. I know 22 and I know 15, right?
Yes.
Okay, so this is a side, angle, side.
Sass.
So whenever I have SAS, what law?
Law of sine.
Law cosine. Law cosine. That's law cosine. So it's SAS, law cosine. So in that case, I'm looking for the distance here. So in this case, it's going to be V equals square root of 15 squared plus 22 squared minus 2, 15 22 cosine of 80. All right, so do you guys plug them all in yet?
24.4.
What is it?
24.
24.4?
Yeah, which is basically 24.
You guys agree? Does the note say the same thing?
Yeah, that's
Oh, okay. I just couldn't remember how to do this one real quick, so I was like, ah, dang it. Okay. So I totally forgot. Just make a triangle.
more close to that.
I know, right? Ah, dang it. Okay, so we get that. All right, ready? Any real numbers? Okay, it's called tip to tail. Okay, it works. Okay, so now here's your two dogs going in two different directions, right? Okay, so magnitude U is my cockapoo, and then the magnitude V is the chewini, right? Okay, going in two different directions. So as you're walking those two dogs, you're going to end up somewhere in between, but that chewini is going to end up pulling you more towards that way, right? Okay, so basically, this is what you're going to do. You're going to add these two together. Add these two together. I just added the vectors.
That was exceedingly simple.
Yeah, because look, the cockapoo is pulling you to the, in this case right here, I'm going to my, okay, which way? To the left, okay? But not as much as the what'd you call it? Chewini. Okay, the chewini is pulling it further. So that's why you're going to end up more in that direction. Okay? Or we could do it tip to tail. Tip to tail's here. Watch this. Here's tip to tail. So I'm going to combine these. So I go this way first. Now, you're giving someone directions. Where do you go from here? That way. So now you go left 2, up 1. Left 2, up 1. That's tip to tail. Okay, let's do this one. Yes, you're getting dragged in both ways, right? This is where that man, what's that dog name? Chewini. The chewini saw that cat, and you know it's going to go after it, right? Yeah. And that cockapoo is just like prancing around, you know, just tick, 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 and then you're like, boop. Anyway, so you're going in two different directions. So which way are you going to end up going? You're going to end up following the chewini, right? Okay. So put those together. I get what? 2. And put these together. What do I get? -1. Bam! That's like 2 semesters worth of physics I just did right there. What? Okay, so okay, here's another one. Find and illustrate the following. I don't know. What are we doing? Okay, where's you? Okay, so here's you. All right, so this is actually a scalar now. Listen up, this is scalar. So, this one says 2v. So what am I going to do to v? 2 times v. 2. We get vector of 8, 6. There we go. Super easy, right? Okay, so we got that. And now what about that what's the other one? 3u. 3 times u. So 3u is negative 2 and 1, which I get negative 6 and 3, right? And we're trying to find this thing right here. We're trying to end up with that. So it says 3u minus 2v. So mathematically, it's going to look like this. 3u, which was this right here, right? 3u, it's going to be negative 6, comma 3, minus 2v. That was this one right here, right? Right? Now, I've been teaching you guys adding, right? Just add the x's and add the y's, right? But if there's a minus sign in between, what do I have to do with that minus? I need to distribute that minus sign there, right? But only to the second one. So since these are both positive, that's going to be a negative 8 and a negative 6. So negative 6 minus 8, negative 14. Positive 3 minus 6. Anyway, are we good?
Yeah.
What's up? In a second. I'm almost done recording. So, yeah, I gotta take a break from recording this to go check out a Chiweenie. Ah, crap. I'm almost out of time. I'll do this. You know, how about this? I'll finish this on. Yeah, Tuesday. I'll finish it Tuesday. All right. Like, share, and subscribe.